All right, class, let's take a look at some of the vocabulary words we'll be using for today's lesson. So, since we're focusing on the state of matter, the first vocabulary word we will probably encounter is weight. Can anybody tell me what weight is? Ethan, speak up. Weight is how heavy something is. I think you're on the right track. Let's find out. A body's relative mass or the quantity of matter contained by it. How heavy something is. You're correct, Ethan. Weight is the amount of, how heavy something is. Is it really heavy? Is it not heavy? Is it light? Right? Has anybody ever seen a seesaw before? Have you been on a seesaw? Right? Phoenix, how do seesaws work? Exactly. When somebody sits on one side, the other side goes up because their weight is pushing that side down to let the other person go up. And now when the other person brings their weight down, that other side will go up. Right? Let's move on. Good job, guys. The next one is volume. Can anybody tell me what volume is? Genesis? No, not the volume of your TV, sweetheart. Volume in the state of matter is the amount of space that a substance or object occupies. In other terms, how much space something takes up. So check this out, right? Let me just get this chair right here. You guys can't really see it. I'll show you here. So here's my chair, right? If I'm sitting here, say I take a seat in this chair, right? You guys probably can only see the top of my head right now, right? Say I'm taking a seat in this chair. Can Carly Annie sit here? No, because I'm taking up this space, right? She can sit somewhere else. She can sit next to me, in front of me, behind me, right? But she can't sit in this seat because I'm taking up this space. She can't be in the space that I'm in. She can't exist in the space that I'm in, right? Same way as how Zakia is sitting in her seat, but, if Michael came along, he can't sit where Zakia is because Zakia is sitting there. Their spaces would not, that space doesn't allow for both of them to be there. Right? Because they're taking up that space. That's what volume is. Right? Put this chair away. Some examples of this is this room, right? Can somebody point out something that takes up space in this room? Oh, Serena. The bed, right? The bed is taking up a lot of space in that room, right? And you can't be in the space in that bed. You can be on the bed. You could be next to the bed. You could be sitting at the side of the bed, but you can't be where the bed is exactly, right? You could be around the bed. Another thing that takes some space in this room. Let me see more hands. Rashawn. The mirror, right? The mirror is on the wall. You can't be where the wall is. Like, you can't put your hand there and exist in the same place as the mirror. You could place your hand on the mirror. You could place your hand next to the mirror. You could place your hand above the mirror, below the mirror, on the dresser, right? On the cabinet, but you can't place your hand where the mirror is exactly because the mirror is taking up that space, right? Let's move on to another one. And then, of course, water takes up space in the glass. We'll get to that later, though. Don't worry. When we focus on another vocabulary word. Let's do matter, right? Can anybody tell me what matter is? Matter. Yeah, Sadia? No, it's not really how something. Oh, okay. So matter is, how things are important, but in the terms of states of matter, when we're talking about the science, matter is a physical substance, right, that occupies a space and has a weight, right, a relative mass, and we know that mass is weight. So let's talk about that a little bit, right? Something that has weight and takes up space. What has weight and takes up space? Come on, Yariel. Dogs have weight, right? They're pretty heavy. When you pick up a dog, they're pretty hefty. They're like babies, right? And they take up space, right? Right? If a dog is sitting here, I can't just go where the dog is because the dog is there, right? So that takes up space. Yeah. What else? What else we got? What takes up space and has weight? You think soda has weight and takes up space? Why not? Why don't you think so? Can someone help Galicia out? Do they think that soda takes up weight? Takes up space and has weight? We'll find out. We'll find out. Let's see. Right? So we have dogs, right? Dogs have weight and takes up space. Do we have weight and takes up space? I have weight, right? I'm pretty heavy. And I do take up this space. If I'm standing here, Rashawn can't come and stand where I'm standing, right? He can stand next to me, right? So I take up space. So I have matter. I'm made of matter, right? You guys are made of matter. Your desks are made of matter. They have weight and they take up space. Your chairs, pencils, markers, erasers, book bags. Beautiful work, people. Beautiful work. Buses, that's a big one. They take up a lot of space and have a lot of weight. Let's not get into that right now, though. So let's move on to solid. So solid is our first form of matter, right? Can somebody give me an example of a solid before we get into this? Solid. Anybody ever heard of a solid before? Ooh, ice cubes. That's a great example. Ice cubes are a solid. What else? What else? What else? What else is a solid? Shirts. Shirts are solids. Okay. Doors. Doors are solids. All right, let's get into this. So, a solid's particles, the molecules, the little small parts that make up everything, are packed closely together. As a result, solids have a definite shape and a definite volume. So what it means by definite is that they're always going to stay in that shape. They're always going to take up that same amount of space, right? So check this out, right? This little cube I have. This cube is always going to stay in this shape. It's always going to be a cube, right? And it's always going to take up this amount of space. So in my hand, it's always going to take up that amount of space. No matter where I move it across the room, it's always going to take up this amount of space, right? Here's an example of how the particles are packed closely together. You see they're kind of shoulder to shoulder, all packed up like sardines, right? And here's some rocks. Rocks will always have that shape, right? No matter where you move it, it'll always keep its shape, unless it breaks, of course. Let's move on to liquid, right? So, liquids. Anybody can give me an example of a liquid? Water, soda, milk. Okay, I think you got a little grasp on liquids. Okay. The particles of liquid are close together, right? Just like solids, but are always moving. They're able to slide past each other, and as a result, they have no definite shape, but they have a definite volume. So what it means by no definite shape is that no matter where you put the liquid in, it'll always take the shape of something else, whatever it's in. It has a definite volume because it'll always take up the same amount of space. So a good example of this, check this out, right? I have these two containers, right? There's a water bottle full of water, there's a cup. Put the cup down there, right? Actually, let's move it around here so you guys can see it better. So I'm gonna pour the water from this bottle. You see how it takes the shape of this bottle into this cup. Let's see what happens. Make sure I don't spill here. Right? So, the water is no longer in this bottle, right? Is it still the shape of a bottle? No, it's the shape of the cup. That means it has no definite shape. It can take the shape of a cup. It can take the shape of the bottle if I pour it back in there, right? But it has a definite volume. Meaning, if I pour this water back into this bottle, it'll fill to the top, just like how it was before. And if I do the bottle back into the cup, it'll fill it up to this line, just like before, right? So that's what we mean by no definite shape and a definite volume, right? Just like these Pepsi bottles. They have different shapes. The cans have different shapes, but they all have the same volume. They all contain the same amount of Pepsi. Obviously, the cans not, but the bottles make, depending on where you pour it from and how much liquid is in the bottle. Let's move on to gas, right? Gas is very interesting. Can anybody tell me an example of gas, right? That's a funny answer, Ethan. Yes, farts are kind of gas, yes. But we need a little more of an appropriate answer, right? Air is gas. Smoke. The smoke from a tea kettle. Does anybody know if that's smoke or something else? Well, we'll get into that, right? The definition of gas. Particles in gases are always moving randomly in any direction. So the particles instead of being packed close together, instead of being all shoulder to shoulder like solids and liquids, they're kind of moving. They're always moving, right? And they're always moving randomly. Like if you guys got up and just ran in random direction, I'm not gonna do that because you guys might get hurt, right? And the space between the particles is large. So as a result, gases take the shape of their containers and they have no definite shape or volume. So what we know about no definite shape? Janaya, right? No definite shape means that whatever container it's in, it'll take the form of that container, right? And it says here that it fills their container, right? It takes the shape of their container, kind of like liquids. And no definite volume, what do you think that means? Anybody? Isaac, right? If you put this much air into this balloon and then you take it out and put it in this balloon, it might not be the same amount, right? It might not take up the same amount of space. One balloon might be more deflated, it might have less air. So let's see our examples here, right? These are the particles in a gas. See how they're separated together? They're not like liquids and solids where they were packed closely together, right? They're moving around, they're separated. There's large spaces between the particles. So I have another example with this glove, right? So check this out. I'm gonna blow up this glove. I'm gonna put air into it. Air is a gas, nice. So here we are, right? Check this out. So we know that gas fills the container that it's in, right? The gas is filling this container. Check this out. I'm gonna poke in one of these fingers, just like that, right? And you see how the air has adjusted to fill the rest of the container. This finger is gone now, but the air is still filling the container because it's now filling the rest of it. Now let's look at this. I'm gonna let go, and the air filled out this finger again, right? It's filling the container, right? Do we think that this has, that gas has weight and a shape? Ooh, sorry. Do we think that gas has weight and a shape? What do you think behind it? Gas has a weight and a shape. Okay, you think so, huh? Well, here's what I'm gonna do. If this has weight, I'm gonna drop it. And if I drop it, that means it will fall. Ready? Oop, it dropped. That means it has weight. And what do we know about the space? Does it takes up space? If this glove is here, can I put my hand in it? No. I put my hand around it, I put my hand on top of it, the bottom of it, the side of it, but I can't put my hand where it is. So it does take up that much space. So yes, gas is a form of matter.